Hi, this is a recording of Router-CIM cutting 3D solid models of a kitchen cabinet and an entire kitchen, whole room full of cabinets from a kitchen. So here we have a 3D solid model, and this one was actually created by one of the popular cabinet design programs on the market. It is all 3D solids. You can see the cabinetry there. You can see the entire kitchen laid out. So what we do is we go into Router-CIM and we select the Solid-CIM command. And Solid-CIM allows you to select your 3D solids with the window. Now in this model I've got dishwashers and sinks and refrigerators and some extra components in there. Those will be filtered out by the Solid-CIM program. We have some settings that allow us to filter out small parts, thin parts, thick parts. We've got all different settings to filter those out. Otherwise, we could just not select them in the Solid-CIM command, or we could freeze the layer, turn the layer off. If it's Inventor, you would suppress the objects before you issue the command on there. So this is now taking each one of the 3D solids, and it's doing the feature recognition on them. Solid-CIM determines which side of the part should face up based on the side that has the most machining. It also takes and rotates the part so its long direction is going to be the grain direction in X. Now we can also specify a grain direction as well. We could specify a grain direction using a grain arrow right on the solid. You can also add additional features to the parts. When they're feature recognized, you can go back and add additional features like two-dimensional drilled holes or any other kind of geometry, text to be engraved. You could put some text on there for the nesting program so you can see it when it's laid out on a nest. You can identify the part, although you'll see that Router-CIM also identifies the part by a part number. And at this point, it's just going to take a few more minutes for the feature recognition to complete, and all the parts will be feature recognized. Here, with all 901 parts feature recognized, Router-CIM can now go and lay the parts out. We can pick the layout command in the Solid-CIM, and all the parts are laid out showing their grain orientation. And this just takes a second to show all the parts laid out flat. There's, as you saw, there's 900 parts in this assembly. Those all be laid out flat here in just a second. There you can see all the parts laid out. The features are recognized. Drill holes are placed on a specific layer. Dados are placed on a specific layer. And each part is laid out with the geometry right on top of the 3D solid. Here you can see the dados being extended beyond the edge of the part, and that is on a separate layer. Here's a rabbet cut. It's got the width by the depth. There's drill holes here on certain layers. There's the actual 3D solid is still there. You can see if I select the hole, there's a circle on this specific layer. So now what we do in Solid-CIM is we export all the parts, and this will create us a CSV file that's a cut list of all the parts. So we go into the export button. It's going to create this CSV file for us. And at this point, all of the individual parts are exported into a folder. And we can actually see that folder being created. Here's the folder with today's date and time as the parts are populated in here, and the cut list is created as well. So all those parts are being exported. Here we've got all the parts exported. At this point, we can exit this AutoCAD session. By the way, there are some pieces that were ignored here. That's the stove, and the wall was too thick, and the countertop was too thick. Those are some of the pieces ignored. We can exit that AutoCAD. Here I've got my components exported as individual drawing names, and it's created this cut list for us that has the name of the part, the material, the quantity, and then a panel dimension for us. Some of those parts were multiple, so you get different quantities in here. What we can do with this CSV file is right-click and cut with Router-CIM Automation Suite. That's the last step here, as now Router-CIM will start up and import that cut list, create a job, process each one of those parts, give me the program for the single parts, and give me the program for the nested sheets and all the different materials that were available in the 3D solid. And we use the AutoCAD material. So when you use the AutoCAD rendering materials, for example, you can specify different materials for your parts. Those will be the materials used in Router-CIM. Same thing with Inventor. We use the materials from Inventor. We also use the part names from Inventor. And you can specify the part names in AutoCAD solids as well using the properties. So at this point now, each of the components will pop up on the screen and make a toolpath and save it for nesting. So this process could take a few minutes now, as each one of those parts will pop up and start making toolpaths. Here's some nested parts. Now some of those parts on the diagonal are longer than they'll fit on the sheet horizontal. So you see how the nesting handled that. We're doing a tool stay down nest. So the tool stays down and connects from part to part without lifting up. As you can see in these nest results, we've got some very tight yields, possibly using 100% of the sheet in some cases. Each of the different materials is nesting right now, and my results will show up in a minute. I'll have programs for each individual part, and then nested programs as well as PDF file printouts and full labeling for all my parts too. When there's material left over on a sheet, Router-CIM will cut that off and save this as a remnant. It's got built-in scrap management, and it'll save that and use it in the next job. Here's a few more of the materials being nested. The labels are being generated, and the job is just about finished. Here's our results. Took about 26 minutes to complete that job, and we've got full results folder here. That's the entire kitchen worth of parts. It's all the parts, the individual parts, and I have my PDF printouts of my nested sheets, all the different materials. I've got the drawing files for each nested sheet is saved as well. So you can open the drawing files and you can make changes to the nests. You can resequence those, make new NC code if you like. There's our full nested sheets. You could see with the shading turned on, the rendering turned on, you could see the individual 3D solids. And here's our stay down toolpath built into each one of these toolpaths. We've got a stay down nest where the tool stays down and connects from part to part without lifting up. So if I just pick one of those up and move it over here, you could see one lead in and one lead out, and the little overlapping bridge connector on all the parts as it connects from one part to the next without lifting up. Very efficient way to run your nests. Okay, so with that, got my nested drawings there. Got labels, full labeling program built in the Router-CIM. It uses Avery labeling. You've got all the labels for all your parts in there with barcodes, picture files. They're all in there. And these are ready to print. The other thing we have is a full summary report that has all of our yields for all the different material sizes. You could see our part yields were in the 90% range on most of those, some of them 98%, 96%. Okay, you've got some nice high yield nesting with the Router-CIM. And it takes a picture of those. It also keeps track of all your tooling, so how many inches of each tool was used and what feed rates they used. There's a variance in the feed rate, so Router-CIM computes, even though I programmed most of my cuts at 750 inches a minute, sometimes it had to go at these different feed rates to speed up and slow down around the parts. And then finally is a summary of all the sheet cycle times as well. So I have summary reports with my cycle times in here, 12-minute cycle times, 5-minute cycle times. A lot of data is generated for each one of those programs. That's Router-CIM cutting the 3D solids